So in our first video of calculus, I want to go ahead and begin by talking about the limit laws. These are the limit laws. That's what these are. Well, actually, I think a better topic for this is, I'm actually going to go ahead and move all these. I don't know that I want to move them down necessarily, because it's just going to leave a bunch of white space there. But I'm going to do it anyway. Move it down a little bit. Alright, and now I'm going to go ahead and I'm going to switch colors back. Switch back to my brush. And we're going to talk about, how to calculate limits. Just a basic concept on how to calculate limits. Now, like I said in my introduction video, I'm just going to be going over the basic review essentials that you're going to need to know for the AP Calculus class. So what I did is I took from my textbook, I took out the limit laws. So these are the limit laws. And I'm not going to spend some time going over them because, A, these should be pretty concrete from your calculus class. And also because a lot of these are common sense, like this one right here. You know, just the limit as x approaches a of a constant is just that constant, or something like the limit of a sum is the sum of the limits, or the limit of a difference is the difference of the limits, or something like if you have the limit of a function times a constant, you can pull that constant out and just find the limit of that function. A lot of these are very intuitive and make a lot of sense. These ones right here. It might be nice for you to know them, but I mean, again, those are A, logical, and B, we also don't use them that often, too. Not as often as, say, these right here. These are pretty often. But these are the limit laws that are the basic limit laws that you should be familiar with when going to the AP test, and you should definitely be familiar with before going on in calculus. These are not absolutely the hardest things to learn in calculus. In fact, this is a pretty easy start to just, I mean, yeah, maybe at the memorize some of these, but I mean, they're very logical. I mean, the limit of a sum is the sum of the limits. You just take the limit of each term, and then add them together. That's not overly complicated as what we'll be looking at later in calculus, which is very complicated mathematics. But what I wanted to do is let's go on and let's take a look at a couple examples on how to find limits. We're not gonna spend too long on these. We'll do a couple parts, a couple different videos on finding limits. But one thing we know about finding limits is, I'm actually going to go back up here. I'm just going to write it on the side. To find limits, I'm going to rewrite this a little bit better. But to find limits, all we can do is we can just substitute. We can just substitute a in for x. And what do I mean by that? Well, if I have say I'm taking the limit as x approaches 1 of x plus 1, well, I can just say, oh my gosh, that's a horrible x plus 1. Well, I can just say it's 1 plus 1 or 2. We just plug in a into the limit, and it pops out a value for us that we can find as the answer. So really, in these examples that I'm going to go over probably like 2 examples, and then we'll go ahead and move on. But in the examples I'm going to show you, all I'm going to do is I'm going to just plug in a into the limit, and then I'll be able to find the answer. Basically, substitution works for finding a limit. I'm even going to write that because I think that's kind of fun. I learned that from a calculus teacher that I did over the summer. That substitution works. Alright, so let's go ahead and do a couple examples. So let's say I have an example. I want to evaluate the limit as x approaches 5 of the square root of 3x plus 1. I want to find what is the limit as x approaches 5 of 3x plus 1. Well, the way we can find the limit here is we can find the limit. Actually, I think first, I'm kind of getting a little carried away. I'm telling you, all right, these are the limit laws, yada, yada, yada. We're jumping right into the limit laws. I think I should probably tell you, well, what is a limit? So I'm going to go ahead and go off to the side and kind of define what a limit is real quick for you, because I think that's also something very important that I probably should have done at the start of the video, so I apologize for not doing that right at the start of the video, but I'll go ahead and tell you what exactly we call limits. Let's say we have, those are some horrible axes. Let's say I have some function. We're going to say that in the viewing window we have, it looks cubic. Let's say that this point right here, I'm going to do it in a different color. This point right here, that's A. And this is some number L, some Y value L. And basically, what a limit is what is the value at A as you get closer and closer and closer to A? What is the Y value at the X value A as you get very, 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 very close to A without ever actually touching L? You get super, super, super close to A. So, like, say in this case, A equals 2. You get super close to 2. Maybe you do 2.1, 2.01, 2.001, 2.001, 2001, 2.0000000 dot 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 001. You can have it as literally as close as you can possibly get without it actually ever being 2. That is the limit at A. So the nice thing is if the value is known, well, we can just substitute an A and that works. What we'll find out is you can also find limits. Say that this is, I'm going to put this in the graph. Say that at this point there was an open circle, and this is B right here. There's an open circle. Here's maybe M. And we wanted to find the limit as B. Well, even though there's no value there, we can still calculate the limit because the limit is whatever value we get as we get super, 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 super close to L. Well, sorry, excuse me, as we get super, 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 super close to B without ever actually getting to B where it's undefined, but we can go like right next to it. So maybe B is -3. Actually, I'm not going to write it right there. Like maybe B is equal to -3. Maybe we look at -3.1 or -3.01 or -3.001 or -3.0001. Or maybe we even look at something like, I don't know, maybe we look at something like, well, that's a little bit there. Maybe we look at something a little bit behind it. Maybe we look at -2.9 or -2.99 or -2.999, or maybe we look at -2.9999999999999, because that's really close to -3. And so that's the idea of a limit, is what is the Y value as you get really, 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 really close to a certain X value, but never actually get to that X value on the graph. So that's what a limit is. So let's go ahead and go back. I'm going to scroll back to our example. Let's go back to our example here. And in our example, I basically said, okay, what I'm asking is, all right, as X gets super, 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 super close to 5, without ever actually touching 5, but it gets super, super close to 5. Well, what number am I getting really close to as I get super, super, super close to 5? Well, one thing I know is that the domain of a square root function looks like this, and it's never has any undefined moments unless it's unless it's before 0. Then it's maybe the graph doesn't exist. In terms of real numbers. So I know that the graph exists, and so if it exists at that point, then I can just substitute 5 in for the limit. So I'm just going to go ahead and do that. I'm going to substitute 5 into this limit. So I'm going to get 3 times 5, and that's going to be plus 1, and that's going to be the square root of 16, which is just 4. So this limit is just 4. The value of this limit, as X gets really, really, really close to 5, the Y value we're getting super, super close to is 4. Let's go ahead and do, let's just do one more example, and then we can go ahead and call it for a video. So we've been doing some calculus for pretty long, and it's starting to get pretty hard. So I'll give your little brains a break. Everyone deserves a break. So let's go ahead and do one more. Let's make it a little bit harder though, because We came from pre-calculus. You know, we know how to make things. We know how to make things somewhat hard by involving trig. So let's review our trig properties, and let's do the limit as x approaches pi. The limit as x approaches pi of 3x. Oh my gosh. Of 3x times the sine of x. So of 3x times the sine of x. Well, let's go ahead and take a look at this for a minute. Well, I noticed that right here that this is a product. There is something that is multiplying these two together. I'm actually going to do that in a different color. I'm going to do that in yellow. There's something that's multiplying these two together. So notice that this is the limit of a product, and we know that the limit of a product is the product of the limits. So we're going to split this up. This is going to be the limit as x approaches pi of 3x times the limit as x approaches pi of sine x. And as we know, substitution is going to work, so we're going to go ahead and do our substitution. We're going to substitute pi in for x, so we're going to get 3 times pi, and then we're going to get sine times pi. So that comes up pretty easy. We know that, oh, my bad, I'm going to put that in green. We know that 3 times pi, that's just 3 pi. The sine of pi, oh, I got to remember, where's pi? Well, I mean, if I can just do a quick sketch, we know that this is 0, this is pi over 2, 3 pi over 2, oh, pi's over here. Sine goes with the y coordinate, it's -1, 0. Sine has to be 0, and I don't care what this value is going to be. If I know that sine of pi is going to be 0, then I know that the limit as a whole is just going to be 0, because the sine of pi, that's just 0. And so so today I think we accomplished a lot, and I'm very proud of our work, and you should be too. We reviewed our limit laws, and we defined what a limit was. We talked for a while about, all right, what is a limit? How do we find a limit? We talked, well, what exactly in English terms, not calculus terms, what is a limit? And then we went back and we did some example problems on finding limits. So thank you guys so much for watching, and I'll see you guys in the next video.